One, so it's important you read the question first of all. So we've got the points A, B, C, have these coordinates here. The line through A is perpendicular, that's going to be really important, to the line BC, and it intersects BC at the point D. So first things first, find the gradient of BC. So find the gradient of BC, we should do our difference in y's divided by our difference in x's. So I have done 7, so 7 take away minus 5, so 7 take away minus 5, and because I did 7 first here, that means I have to do 3 first by here. So 3 take away 6 then, so that gives me 7 minus 5 is 12, divided by minus 3 is negative 4. So that's the gradient of BC. To find the equation of BC for the next part, I use the formula y minus y1 equals mx minus x1, and I substitute those values into that formula. Now I can either choose B's coordinates, so these ones here, or I can choose C's coordinates, and I decided to choose C's coordinates because neither of them were negative, so I felt that made it slightly easier not having to worry about minus signs when I was subbing in. So I had y minus 7 equals minus 4, x minus 3, and then I expanded that, and then I got it in the form they wanted here. Okay. For the next part, part 3, it says find the equation of BD. So what I've done here, I've written a shorthand way of saying perpendicular. You sort of draw a straight line, another straight line meeting it, and draw a little right angle. Perpendicular to BC, therefore the gradient of AD equals a quarter, because 1/4 times minus 4 equals minus 1, which is the condition for being perpendicular. So now I have its gradient, I can sub in either A or D's coordinates, but I don't actually have D's coordinates, so I have to sub in A's coordinates. So I'm subbing in the 8, 4 from up by here. So I'm going to have y minus y1 again equals mx minus x1, so I've just subbed straight into that, and I've then brought everything over to keep my x coefficient positive. But you'll notice by here, I've actually brought these two bits round to the other side, just to make my job a bit easier in part B, so I can solve via simultaneous equations, because I know D is where BC and AD meet, so by doing that I've got simultaneous equations. So this was my equation of BC, this is my equation of AD, and where they intersect, that is where my D's coordinates are. So one thing I could do is, I could do like the GCSE method that we did, so get the x coordinates the same, so 4x and x, they're different at the moment, so times that by 4, or do the same with the y's, but I prefer to actually, if I've got x equals on its own here, I prefer to get x on its own and then substitute the value of x, so I'm saying x is identical, is equal to 4y minus 8, then I can actually change that into equation 1, that wherever I do see an x, I change it to 4y minus 8, so that's the method I've gone for, because I think it's a bit quicker and a bit easier. So it's 4x, so I changed it to 4y minus 8, so I multiply that bracket out, and then plus y, and then minus 19 equals 0. So I've expanded that bracket out and solved it and found that my y value is 3, and then I think up by here, I have then subbed in my y value of 3 into 2, so that one there, so 4 times 3, take away 8 is 4, and then I've proved that my x coordinate is 4, my y coordinate is 3, and if you actually go back and check in the question, it tells you that's what it should have been, so we know that we've got the right answer there already. To find the length of BD, then what I need to do is use this formula here. It's basically Pythagoras Theorem, the square root of the difference in x's squared plus the difference in y squared. So I had a look at the difference in x's, and that was a value of 2. I had a look at the difference in y's, and that was actually minus 8, but it doesn't matter if you have the minus 8 or the positive 8, because when you square it, it's going to turn to positive 64 anyway. And then I got that as being root of 68, and then I put that into third form, as we should always cancel down to third form whenever and wherever we can. So that became 2 root 7. Sorry, 2 root 17. Although looking back in the mark scheme, they've actually given the full marks for saying root 68. For part D, I've drawn something that's definitely not to scale. I've just drawn something to get my head around what's going on. It said that D is the midpoint of AE, so what I did was I just drew a very generic line. Obviously this isn't done to scale because 4 clearly comes before 8 when we're doing a scale, but I said this is my line AE, I know that the midpoint is 4, 3, and to do the midpoint I must add the x values together and divide by 2 to find the middle of it, and I must find the y coordinates together and divide by 2, and that's what I'm saying by there. So I know when I do 8, add the e coordinate, which I'm just going to leave as x2, and I divide it by 2, I get d's coordinate 4. So then all I've done is rearrange this to get x2 on its own, and I took the over 2 round times by 2, then took the plus 8 over and it became minus 8, so x2 was 0. And for the other one here, I had 4 plus y2 over 2 equals 3. Brought the 2 around, took the 4 over and got y as 2, and my coordinates are, and I should have written this in actually, should have been e is 0, 2. Okay. Question 2, simplify the following. So surds always comes up, always in this format. It's called rationalizing the denominator. We don't want any square roots on the bottom. So the way that we get rid of them is we look at this bracket and we treat it for more or less identical thing there, except we swap the sign from being whatever it is there to its opposite there. Okay, that will always make sure that these two things cancel here eventually. But whatever I do to the bottom, I must do to the top of a fraction to keep it equal. So I've times top and bottom by 4 minus root 7. I've then expanded out those brackets there using FOIL, and I've then just collected my like terms and put the positive term at the front, so that became 18 root 7, 8 minus 35 became minus 27 over 9, and because 9 goes into 27 and 18, that filled me with a bit more confidence, because that's telling me that I'm probably right, that because that denominator goes into both of those, then they cancel, hence leaving me quite a nice answer to finish off with, which was 2 root 7 minus 3. For the other part, what you need to be thinking of is the biggest square number that goes into each of these. So the biggest square I could spot there was 36 times 10, and then the square root of 36 is 6, so that's how I got that. And then because that's a root 10, I'm expecting all the others to have a root 10 in them. Okay, now minus 2 times root 5 cubed. I've got to do the root 5 cubed first, so that's going to be root 5 times root 5 times root 5. So that's going to be 5 root 5. And then I've got to times that by root 2, so that's going to give me minus 5 root 10. Now the last one, I could do this in a couple of different ways. I could do 30 times 8 in a square root, which would be root 240, and then divide that by 6, which is root 40. Or I could have done root 30 divided by root 6, which is root 5, and then root 5 times root 8 is also root 40. So it comes to root 40, and I know that can't be right, or it can't be my final answer, because it hasn't got a root 10 in it, like these two here. So 10 times 4 makes 40, and then the square root of 4 is 2, so it became 6 root 10, minus 5 root 10, minus 2 root 10, which gave me a final answer of minus root 10. Question 3, there's a sneaky bit in part B. I didn't think that was obvious as part B, but we'll do the first bit first. It says the point P has the coordinates 3 minus 5 and lies on C. Find the equation of the normal. They put that in words there. Find the equation of the normal to C at the point P. Okay, so to do that, we need to differentiate it to find the gradient. So the differential is 4x minus 10. At this point P, 3 is the x value, so I'm only subbing the 3. The minus 5 is irrelevant, it doesn't do anything. So we get 4 times 3, which is 12, take away 10, gives me a gradient of 2, but that will always find the gradient of the tangent. To find the gradient of the normal, it's always got to be whatever that times is by that to make minus 1 the condition for being perpendicular, as we've already talked about. And then we use exactly the same formula as in question 1, y minus y1 equals m, x minus x1. And we start subbing into that my value of p here. Now that minus 5 is useful, so I can sub in to find the equation of the normal. And it comes to being x plus 2y plus 7 equals 0. Did they give us that equation? No, they didn't. I could have had it as being the complete opposite, being I minus x minus 2y minus 7 equals 0 if I subbed all of these over to the other side. Okay. For part B, it says that the point Q lies on C such that the tangent at C is parallel to the x-axis. So what I've actually drawn there is something that's parallel to the x-axis. So therefore, that means its gradient is equal to 0. Okay, so to find the point Q, what I've done is I put my differential equal to 0. So that's coming back to all the way by here. This guy here, I put that equal to 0. And then I have solved the equation 4x minus 10 equals 0, taking the plus 10, the minus 10 over to become a plus 10, then divided by 4, 5 over 2 or 2.5. Okay, so for completing the square, we need to get it in this format here. So the first thing we can see is that 2 goes into that, but only do it with the first 2 bits. Can you see there the C's on its own? You leave the minus 8 outside. So my first line should look like this. 2, but then I have to halve that, so that just becomes x squared, and then half that to get minus 8x. And that minus 8, you leave outside by there. To then start completing the square, and this is the bit that is very, very easy to forget. You halve this b coefficient here to get 4, and you square the pair of them, and you remove the square from there. So that would give me x squared minus 8x, but it also give me a plus 16, so I must take off that 16. But that must stay in the brackets of the 2. Eventually that's going to get doubled, and that's where the most common mistake lies at AS level on this. That is still minus 8 outside. When I expand the bracket, I get a minus 32 there. That 2 just times us by that. Minus 32 minus 8 gives me a minus 40 altogether. Then it says for part B, using your answer from part A, find the least value of this thing here and the corresponding minimum value of, or the corresponding value of x. Now, I noticed my original thing here, which was from part A, was equal to that thing when I divided that by 2. So what I did then was, because I've already done the work on this thing here, I then changed that to its completed the square version. So 2x plus 4 squared minus 40, sorry, divided by 2. Now when I'm dividing by 2, that thing in the bracket doesn't actually change at all. Because these two things are timesing, I can just cancel that 2 there. So 2 divided by 2 is 1, which I can just leave as blank. You could write 1 if you wanted, it's not wrong. And then that 2 divided by the 40, because that's takeaway, I do have to cancel that one as well. 2 divided by 40 is 20, and that's equal to this thing the whole time. Maybe I should have written that down there and there as well. And then to find my least value, it's what makes that bracket 0, so x equals minus 4, and then y is whatever's left over. So if that went to 0, you try and pretend that it doesn't exist anymore. So pretend that doesn't exist, what's left? Minus 20, minus 20. So my x value being minus 4, my y value being minus 20. Part B, it says, write down, or using the binomial theorem, write down the first 3 terms of the expansion of this thing here. Now the fact that 7, for me, 7 is probably the last number I'd do this, I'd write out Pascal's triangle up to the 7th row, or certainly up to the row where it goes 1, 7. Okay, so Pascal's triangle there, so notice the pattern there, these two add to make that one, these two add to make that one, these two add to make that one, etc, etc. So 10 and 10 make 20, 5 and 10 make 15, etc. So then I get 1, 7, 21, 35, 35, 21, 7 and 1, but I don't need to use all of those, it only asks for the first 3 terms. So this thing here, there's my coefficients that I've got from Pascal's triangle, and then it's going to be that this one goes in descending powers of 7, so 1 to the power of 7, 1 to the power of 6. Oh, small mistake there, let me change that. That should be 1 to the power of 5. It doesn't make any difference though, because it is going to be 1 to any power is always 1. So it should go 7, 6, 5, whereas this one does the opposite, it comes up from 0, so 0, 1 and then 2. Okay, and then I've just solved what those are. Just be careful on the last one, you've got 21 not times by 2 but 21 times 4, because 2x squared is 4x squared. Okay, so that becomes 84x squared here, and I've said plus dot 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 because I know it continues because I've got these remaining coefficients, but it's too hard to do that in a calculator, you can't be doing that in your head, it'll take all day. For part B, it says use your answer from part A to find the first 3 terms of this expansion. So it's this thing here with what we just expanded. So you do 1 times by the 1, then 1 times by the 14, then 1 times by the 84, and then you do minus 4 times by the 1, minus 4 times by the plus 14, and then minus 4 times the 84x squared. But because it wants the first 3 terms, I've spotted I'm going to have 1, then a 40, well, then an x term, then an x squared term. That's going to give me an x cubed term, so I haven't even bothered working that out because I know that will clearly be the 4th term, and it only wanted the first 3 terms. So that's how I got my answer there. Okay, question 6. So we've got some form of quadratic, and we're told that it has 2 equal roots. It says assuming that it has 2 equals 0, it has 2 equal roots, and we're asked to show that that it equals that. Okay, so what I did here was I picked out my A value, my B value and my C value, and I've tried to colour code those by here, and I've substituted them into b squared minus 4ac, and the reason why I put it's greater than 0, sorry, is because I'm told it has 2 equal roots. So I've done b squared, so b squared became that one there, then minus 4ac, so minus that value there and there, and then I started expanding it, and eventually, what does it get to? So there, I've got 12k squared plus 24k plus 21, and can you see there it's a slightly different value, but I can see that 3 goes into each of those things there, so I divided everything by 3 to get that thing there. It then says for part 2, it says, hence show that there are no real values of k such that the quadratic equation that thing equals 0. So this thing here, what I tried to do was I tried to factorise it, but I could see that there are no pair of numbers that times 28 and add to 8. So I had to put it through b squared minus 4ac, and when I put it through b squared minus 4ac, now that isn't the same one as the one up here. It's a different one now. It's using, once I've cancelled this down to its lowest terms. So a is equal to 4, b is equal to 8, c is equal to 7. And from here, I worked out that 64 minus 112, which is clearly less than 0. And if that b squared minus 4ac is less than 0, then the definition is there are no real roots. Okay. For part B, I had this fella here to cancel down. And I had to find the values where it's greater than or equal to 0. So you start by timesing the first and the last term, but don't forget the sign here. So that gives me minus 36, and then my b term here becomes what they add to. So a pair of numbers that times the 36 and add to minus 9 are... so what I do then is I drop just the squared term from the 4x squared and get 4x and 4x. And then here, if you can cancel down any of these brackets, you must do. This one cancels down, they're both divisible by 3, but this one isn't, okay? Now I know the first one isn't done properly because 4x times 4x is 16x squared, and I had 4x squared, so I knew one of them must cancel. Finally, I'm looking for where it's greater than or equal to 0. So I've drawn what that curve would look like. I know where it hits the x-axis, so it's by solving that equal to 0, so positive 3 and minus 3/4, and it's greater than or equal to 0 when it's above the x-axis. Here it's just getting larger and larger and larger, so when the x value is less than minus 3/4, that's when it's above 0, and vice versa here. You must write this word or x is greater than 3 by here. For question 7, differentiations from first principles. I'm not going to go through all the steps on that. Pretty standard piece of maths. It comes up every year. Need to know the definition. Basically, whatever your first equation is, you say y plus a little bit of y, which we call delta y, is equal to x plus a little bit of x, which we call delta x. Expand that bracket, which I've done over by here, and then times it by 5. You then do 2 take away 1 to find out the gradient. It comes to being this thing here, and dy by dx is equal to this delta y divided by delta x, as the limit of delta x tends to 0 as that gets closer and closer and closer to the point. Okay, go back to your lessons if you're unsure on that, or come and find me to go through, but it's pretty standard, comes up every year. And then finally for part B, it says differentiate with respect to x. I'm saying differentiate with respect to x, this thing here. So I times by the power, so 6 times 2/3, and then this power decreases by 1, so 2/3 minus 1 is minus 1/3, and then times by the power, so 5 times minus 2, and then x to minus 3, so minus 2 take away 1 is minus 3. It's absolutely fine to leave it in this format here, but if you wanted to, you could make it look a little bit nicer, which is nice if you're subbing in a value of x. Say we're told that x is equal to, say 27 or something like that, or say maybe 8, then it'd be much easier to sub it in that format there when we haven't got a calculator. For question 8 here, when we're asked to solve this cubic, what we need to do is we need to start subbing in values that we think could be an answer. So first of all I subbed in 1. You'll see here I didn't actually work it out because I was starting to do the maths. 8 minus 2 minus 7 is minus 9, and then plus the 3. It clearly isn't equal to 0, so I've just said not equal to 0. So then I tried minus 1, and when I subbed in minus 1 I found that it does equal 0, and if it equals 0 that tells you that x plus 1 is a factor. It's always the opposite of what you think here. So x plus 1 is a factor. So I put x plus 1 here. I was able to work out 8x squared and plus 3 really easily because x times what makes 8x cubed? Well, the only answer is 8x squared. And then similarly here, 1 times what makes 3? Well, it's only 1 times positive 3. So what I did then was I wrote down my x here, but I had to try and work out what it was. I know that 1 times 8x squared would give me plus 8x squared. And then I know this times something would have given me x squared, and I knew overall it had to make 2x squared. So 8x squared minus 10x squared makes minus 2x squared, so this had to be minus 10 because x times minus 10x would give me minus 10x squared. Then this fella here, you need to factorise that. So I did 8 times plus 3 to get 24, and I knew they should have added to minus 10, so that pair of numbers is minus 6 and minus 4. And then putting that into 3 brackets, cancelling down where I can, and finding my values. X equals minus 1, x equals a half, and x equals 3/4. And the transformations of graphs. So what I've got here is a graph. This one here, first one's really easy. When it's inside, it does the opposite of what you expect to the x coordinates. So instead of moving them on 5 that way, it actually moves them 5 backwards. Okay, so all I've done is I've moved all my x coordinates back 5. So minus 2 minus 5, 2 minus 5, and 6 minus 5 to get my coordinates here. This one here, inside, does it to the x values again. So my x values are going to switch. So from being 2 here, it's going to then be minus 2. But when it's inside here, it does the opposite of what you expect. You expect them to be doubled. So it actually does the opposite of doubling, which is halving. So after I've switched my x coordinates, so that minus 2 becomes to be plus 2, that 6 becomes minus 6, I then halve each of those things there, so it squeezes in the graph. So minus 2 becoming 2, and then halve it becomes 1. 6 becoming minus 6, but then halve it becomes 3, and then 2 becoming minus 2, but then halve it becomes minus 1. And finally, question 10. So we have got a closed box, very important you recognise it's closed, and we're told the lengths of these boxes. And we're told what the total surface area is, and it says write down an equation involving x and y and hence show it's that, hence show it's that. Okay, so what I did to begin with for part A, I knew the surface area, definition from year 7, surface area is going to be 2 of these front rectangles, 2 of the side ones and 2 of the top ones, because if you've got it on the top, you've got it on the bottom, if you've got it on the front, you've got it on the back, and if you've got it on the side, you've got it on the other side. So 2 of the A's plus 2 of the B's plus 2 of the C's would equal 108. So what I did was I just subbed into that from these dimensions that I had here, and I ended up working out exactly what they wanted me to work out. Okay, so I got x, y on its own and then divided by 6, etc, etc. Now for the volume one, I know that volume is just timesing all 3 sides together, so I've got 2x times y. Now I was going to write that as 2x squared y, but I know an expression for xy already. So I've written that as 2x xy, and then I've changed the xy for what I worked out before, and I've subbed that into here. Okay, and that's how you get the formula that they wanted. To then work out the maximum volume, I've got this this value here for my volume here. To work that out, what I must do is I must differentiate. I then must put that equal to 0 for stationary points to find its maximum and its minimum values. So I put that equal to 0, solve the equation, I find that x is equal to 3 or minus 3, but I've discounted the minus 3. I put it in brackets because I can't have a length of a rectangle that is minus 3. It doesn't make any sense. I've then double differentiated to prove the nature of the stationary point. So double differentiate, coming all the way back to this guy here. Now you can see here I've made a small slip. I've just gone back to what I'm used to. That shouldn't say d squared y, it should say d squared v. And then I have subbed in my value of x, which is 3, and that's gone to be minus 24, and if it's less than 0, that is by definition a max.